And hello! Today in class we are going to learn the properties of powers. What are they for? The thing is that we have learned with you to calculate the value of a number in some degree and said that this notation is convenient for writing large numbers. So today we will learn some properties of degrees, but to do that we're going to solve an example. We need 2 to the power of 7 times 2 to the power of 6. In order to solve this example, we have to multiply 2 to the 7th power and then 2 to the power of 6. What do we get as a result? Well, we've talked about the fact that writing a number to a power is used to write larger numbers. Now we'll see for ourselves. Let's solve our example, 2 to the power of 7. I'm going to write it down as a product. The numbers 2 7 times. 4, 5, 6, 7. 7 times. Now I'm going to write the number 2 to the power of 6. That's 2 times 2 times 2 times 2 by 2 and by 2. 6 times. As a result, if I were to find the value of this expression, I get the number 8,192. That's not such a big number. But the thing is that degrees can be 30th, 51st and 76th, and it will be inconvenient to calculate the value of this expression every time. So what can be done in this case? The thing is that in math we can write the number 8,192 as 2 to the power of 13. So if I were to multiply 2 by 2 13 times, I will have the number 8,192, but we can write the value of our expression as 2 times 13. That's exactly what we use the notation of a number in some degree for. If we were to multiply the number 2 to the power of 31 times the number 2 to the power of 99. It's irrational to write the product of multipliers that are each equal to 2, so I have to write down the value of this expression, and I can write down that the value of this expression is 2 to the power of 130. How did I calculate that quickly? Let's go back to our example with you. I wrote down the number 2 7 times, and then I wrote down the number 2 6 times. The result is that I ended up with 13 2s. And then I can write down that the answer is 2 to the power of 13. What did I do? I added the number 6. The number 6. The result is 2 to the power of 13. Let's see if I found the answer in the second example. 2 to the power of 31 times 2 to the power of 99. I got 2 to the power of 130. Let's check it out. 2 to the power of 31 times 2 to the power of 99 equals 2 to the power of 31 plus 99. And then you get 30 plus 99. That makes 129, and plus 1 is 130. As a result, I got the right answer right away. So, mathematicians use the properties of degrees, and they can be written in the following form. If we need to multiply a to the power of n by a to the power of m, then I can keep the base of the degree and add the exponents of the degree. The result is a of degree n plus m, which is what I applied in the first and second example. I added 7 to the 6. I added 7 and I got 13. In the second example, I added 99 to 31 and I got 130. This is the first property for a degree. There are several other properties for degrees. Let's write them down with you. If I need to divide 2 to the power of 7 by 2 to the power of 6, I will write it down as a fractional number. What will be my result? I will not calculate the value of 2 to the power of 7, but I will write 2 times 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 2 and 2 times 2. And divide in the denominator 2 times 2 times 2 by 2 by 2 by 2 by 2 and by 2. As you can see, it's not exactly a convenient way to do it. And if I were to divide by 2 in pairs, I'm left with 1 and here 1. And in this case 1 and here 1. And as you can see, I'm left with only 1 2. Only 1 2. 2 to the power of 1. I could have gotten that answer. 2 to the power of 7 divided by 2 to the power of 6. The exponents of the powers I subtracted. From 7, subtracting 6 would be 1. The result is 2 to the power of 1. Then we can write down the following property. If I need to divide a to the power of n by a to the power of m, I can keep the base of the degree and subtract them. If the same notation would look like this. Like this, a to the power of n divided by a to the power of m. Then I should also find the difference of the exponents of the degrees. Next property. If I need 2 to the degree of 7 to raise to the 6th degree, what must I do? I must multiply 2 to the degree of 7 by 2 to the degree of 7, multiply by 2 to the degree of 7, and so on 6 times. And then find that value, but I'm applying a different property. If I have 2 to the power of 7 times 2 to the power of 7 repeated 6 times, what can I do? Here's 2 to the power of 7, here's 7, and here's 7, and so on 6 times. The result is 2 to the power of 42. What did I do? Yes, I multiplied these exponents of degree. Thus, I got the following property. A to the power of n and to the power of m. The result is a in degree n times m. Now let's write down more properties that apply to multiplication of degrees. Fourth property. If you have a product to be multiplied to some degree m, in this case, I have to raise each of the multipliers to degree m. The same property applies if we need the quotient to some degree. We have already seen this example with fractional numbers. In this case, I put the numerator to degree m and the denominator to degree m. Today in this lesson, we've only looked at 5 properties, and we're going to apply these 5 properties to solve examples. And today our lesson has come to an end. Goodbye. See you again.